Ah, welcome to Career and Corporate Hub. Dzina ndiko Dani Hlajwayo. Today ndina Rendani Mamphiswana. Dr. Rendani Mamphiswana to be precise. So I'm not gonna say much. Nga Rendani, he is here to tell his story. Uri akone u inspire bana bane baba primary and high school, and also mutu ane akunyango follower into his footsteps ane onobakure. Di Masiara Rendani, welcome to Career and Corporate Hub.
And Masiara with the Kodani.
Yeah.
And Polibo Chino Chipinga.
Okay.
Ambapano.
Yes. So how do I address you, Dr. Mamphiswana?
Yeah, I think for the purpose of this conversation, the doctor part might leave a much more last impression to the young ones.
Go. Okay, now you are welcome. I'm happy to be interviewing you, and I'm very much sure that this interview is going to help someone that would like to follow into your footsteps. So tell me about your background from primary, like which primary did you go to?
Ndoya Matondoni Primary School.
Okay.
Ndika village ya Matondoni.
Yeah,
so ndione enda hone.
Okay.
And it's in our one of the Pipi the waterfall.
Oh yeah, everyone knows Pipi the waterfall.
Yeah, that's a known place by a number of people. Yeah.
Okay.
So yeah, Ndoita primary Ningei 1993 to 1999.
Okay.
That's when I finished primary school. Yeah.
Okay, and were you taught in, like, I know, like for me, a lot of subjects in primary were translated to Chivenda. So I always say I was taught in Chivenda, and then when I got to varsity, it was like a struggle to learn English. Was it also the same for you, like in primary, or?
Yeah, I mean, not entirely. I remember the Afrikaans piece. Yeah, the Afrikaans was taught in some particular way.
Yeah.
So it was actually very difficult to really thought we understood. I think there's certain words we understood, the Afrikaans.
Yes.
Even English was not sufficiently. So I struggled quite a bit, actually, the first 2-3 years of high school. High school,
okay.
Which was quite a transition.
Yeah, because Mbiri is in town.
It's in town, yes.
Okay,
yes.
so from a village, and then you had to do your high school in town. Okay. Yeah, and Mbiri, it's a science school. So, and how was Mbiri for you?
Mbiri was first extremely tough.
Okay, because of the English, or?
I think it was tough because of the change. I mean, you are moving from this village now where everyone is like you.
Yes.
In terms of the social standing and hierarchy in society.
Yeah.
Now you're moving into this space where you are largely right at the bottom on quite a number of things. So the first 2 years were quite an adjustment from that perspective, and that made it very hard. But I think as soon as I overcame that piece, that pace, which was largely from grade 10 onwards.
Okay.
I had a lot more comfort, and I think I could start to exercise a greater deal of my intellect.
Okay, I see. And you did chemical engineering in your undergrad university.
Yes.
Did you always know from Mbiri that you wanted to study or to become a chemical engineer?
No.
What inspired it?
No. I did not even know chemical engineering until I was in matric. So actually I wanted to be a doctor.
Okay, like everyone else.
Yeah, a medical doctor.
Yes.
Because I think that was the ambition of my father.
That's a good one. Because now you're not a medical doctor, so to be specific, a medical doctor.
So I think the ambition at the time was to become a medical doctor, because I think my father wanted to be one, or he thought that would be a good career.
Yes.
And I think when I was in matric in 2004, I actually applied to be a medical doctor, and I was accepted at University of Cape Town and University of Witwatersrand, and I think even the University of Pretoria.
Okay.
And then I came for career. We had a career expo that we came to the university. So we came to Wits and University of Pretoria. Then I started to look through the books, and I was just like, but no, I don't want to be a medical doctor. And on that day,
so you were one of the bright ones who went through the prospectus.
when we came to
But
the career
I went,
day,
I didn't even look at the prospectus.
ah, come on.
Which I advise that, you must always do research when you're looking for a course to study after matric.
Yes, yes. So I mean, even then, so I'd done some reading, but then I had not. It was just something I thought I'll do.
Okay.
But also, I think the medical doctor piece is also around. You want to help. I think we grow up where we grow up, and
Yes.
especially as black people as well, in a village setting. There's always this thing of you want to help.
Yeah.
But I think what we don't appreciate is help can be initiated
In any
and
way.
can be deployed, can
Yeah.
be manifested in many
Yes.
ways.
Yes.
Not
yes.
just being a medical doctor.
Yeah.
So then, when I went to the career day at that particular time, then I called my mom. I'm like, no, I'm not doing medical thing anymore. My second choice was chemical engineering.
Okay.
But even then, chemical engineering, I done it through the process of elimination. It's
What do you mean by that?
It's a very important process of saying, I don't think I'll like this. I don't think I'll like this. Oh yeah,
Okay.
like I look at the engineering things.
Yeah.
There was mining, there was electrical engineering,
Yeah.
there was metallurgy. And I was just like mining. I'm like, I don't want to be a miner. No, you know. I mean, I was not even correct around the actual thing.
Yeah.
So, but then at the end, I think in engineering, I'd settle. I can do chemical, I can do electrical, and I think I think because you were allowed to have like 3 options,
Yes.
including the medical. So then chemical
Yeah.
became my second. But then afterwards, I changed to chemical. But the selection of chemical for me, so there's some books we read, when they talk about designing plants.
Okay.
And plants,
Okay.
it's not the plants of the trees, it's plants as in chemical processes.
Yeah. I
So
was about
anything-
to ask, like, is
No, it's
maybe
not- Yeah.
chemistry?
Yeah, so it's more
influenced
plant.
it, or
There was some element of chemistry, but I learned actually when we did chemical engineering university, it's less about chemistry.
really?
Yeah. So
Okay.
there is a study in chemistry where you get to the depth of the
Okay.
fundamentals of
It's
chemistry.
not about balancing the equations of
It's
chemistry.
it's so chemistry is a tool of chemical.
Okay.
In fact, it's to say chemical engineering, it's actually incorrect. It's supposed to be called process engineering.
Okay.
Yeah. So
Please elaborate more.
no, it's about processes.
Okay.
So it can be a process of making bricks. It can be a process of
Yeah.
so not every process is necessarily chemically inclined. Some processes are just pure a separation of things. If it's a
Yeah.
process of making wood, you literally just cut in the trees and you warm them up and you dry them up. There isn't really any form of chemicals, but
Okay.
I think it originated from chemical in the sense of chemicals, that you
Yeah.
are combining chemicals.
Yeah.
But people who really understand the fundamentals of that are the chemistry people. But so chemical engineers work a lot with chemistry graduates because they understand when what will do what and what are the conditions. If you change the pH, if you
Yes.
if the solubility is like this, I mean, I can look at the graph and make sense. Say, oh yeah, I must choose that process because of that. But the fundamentals are honed by but it's an important tool for us as process engineers or in the process engineering domain.
Yeah. So after studying chemical engineering, you become a process engineer.
Yeah, well,
Usually.
chemical process engineer. But largely the common name is process
Yeah.
engineering.
Okay.
Hardly
Yeah.
it's called a chemical engineer because it is confusing.
Okay. And so how was your studies in varsity? Were they hard? How was it like, the navigation of moving from Limpopo to...
So I mean, I think there was some level of transition. First year wasn't bad for me.
Okay.
And I think we had a great camaraderie from the guys from Mbiri. So there were a few of us on campus, and we met other vendor people along the way, and we were
the
able
vendor group.
we were able to build
They
up.
say everywhere, like where there's vendors, they all
There's
come
always
together.
they're coming together. So we're able to build up on that.
Okay.
So it wasn't that bad. I actually did quite well in my first year.
Okay, that's good.
But then the second year was a lot harder because we're getting deeper into some of the actually we're getting deeper into the fundamentals of process engineering. You know, like really, and that was quite tough in some instances. But I think you know, I was still able to figure my way out and have to prioritize certain concepts. I mean, there's concepts of heat transfer, concept of some level of fluid dynamics, which you have no idea.
I know.
So, but then I think the key, from a strategy point of view, the key is when you face those moments, you must dial in to that thing that is confusing you.
But what would you advise for somebody that is moving from like the rural area and then they go into varsity where it's like a big transition?
I mean, I think the key, and these were the words of one of you know, the Housecom member. I stayed at NS Oppenheimer EOH. It's actually based at the Vets Business School campus. And one of the things he said quite early, and I became a Housecom member in my last year, and it was the same message that we're passing on to the young ones. You must remember why you are there.
Okay.
Your priority is the academics.
True.
So if that is flowing, you can have the rest of the fun.
Okay.
If that is not flowing, you must close the rest of the fun and then come here.
That's actually interesting. So when you say you must know your priorities, and then when that is flowing, you must have the rest of the fun.
You can add other things after that.
Okay, so it shouldn't be just academics.
Yes, of course. But if the other things are hindering,
then it's
the
a
academic,
problem.
because you can only enjoy the other benefits as long as you are a student. I mean, if you are kicked out of campus, you don't have a student card. That's a basic thing. You don't have a student card to enter the campus.
Okay.
So really, you need to make sure that you retain your student card. Then if that is flowing, then you can pull back into other things.
Okay. And so currently you have PhD?
Yeah. So I did a Doctor of Philosophy, PhD, in innovation management and policy.
Okay.
So that's what I specialized on, and something I graduated on that last year, May, at the University of Johannesburg.
Okay, that is nice. And looking at like the innovation, I mean, we in the like fourth industrial revolution era, and some of the careers that kids or like people from high school are pursuing, they don't have much future. So what other qualifications did you do?
Oh no, so along the way, I think so. When I finished the undergrad, engineering, I went to work for Sasol. I worked for Sasol for about 6 years. After 6 years, I could see that, you know, having a single qualification was not as competitive anymore in terms of even your own progress. So I went back to school, and I specifically chose a field in technology management at the University of Pretoria, which was precisely to understand how do you develop new ideas and how do you commercialize them. And that's where actually I started to get an appreciation around innovation, around policy, and that culminated into the focus of my PhD study. But I think so I did that. So I did honors and masters in technology management. I also did a study in risk management, because everything about, you know, even just investment, even just your own life, involves some level of risks of which technologies we want, when we want them, and what they must do. And this is where the world of government and policy comes in. And South Africa, for example, supposedly, and this was part of the greater focus of my PhD, as a policy on science, technology, and innovation. It's not a very brilliant policy, but part of it, when you have a clear policy, speaks about selection. Which science must we get involved in and why? Which technologies must we get involved in and why? Which innovation? So as society, we must be able to make the choices. So for example, South Africa as it is now, with the high unemployment rate, there's a need to balance the pace at which we deploy the technology. And when my first paper that I wrote for the PhD and I presented in India in 2019 was that how do you manage this process?
Hmm.
Because you want it to be as gradual as possible,
Yeah.
but at the same time you don't want not to adopt
Yeah.
because there is competitiveness implications.
Yeah.
But
yeah.
it cannot just be left to its
That
own
is-
device.
That is actually my drive for this project as well. That people leaving high school, they go do careers that do not have a future. I don't know if I should present it that way. Where
And I think that's so. I mean, there's some elements of truth in terms of what you're saying, but I'm of the view that, you know, if a particular qualification is still offered
yeah,
at a particular university,
Mm.
might not be at the high end
Yeah.
of the, if we were to put a scale into these things, right? But I don't think it's gonna destroy the learner by
Okay.
doing that. But if the person thinks, you know, I think I can do this, I think there's value in this,
Yeah.
you know, I don't think I'm gonna destroy the person, right? And I want to come to one of the next point around higher education. Higher education is a highly social environment. By being on campus,
Yeah.
regardless of what you're studying, and provided you're obviously passing, because I mean you must get a paper at the end of this thing,
Yes.
right? It shapes you in a particular way. Like even now, and this is where sometimes the fight for free education in South Africa was misunderstood, or those who understood it fought it, claiming they're not understanding it. What higher education does, right? It shapes your
Yeah.
social capital for life.
That is true. That is true. Yeah.
So there's a need for a young boy or young girl from a particular village to be on campus, not just for the certificate,
Yeah.
for who she means. So I mean, I was in undergrad in 2005.
Yeah.
Right? I mean, I'm 36 now. I mean, in the next 10 to 15 years, who will be running the South African economy? My peers. Where are they? Where did I meet them? On campus.
On campus. Yeah.
Right? So at
Yeah.
some point, and that's part of the investment that the country must make. That the people who we are entrusting, that in future they will run the country, we must bring them together
Yeah.
in an intellectually stimulating and
Yeah.
engaging environment.
So one of the reasons why I'm asking about the future of certain careers is because if you look at in like countries like Germany, yes, they're way ahead of us. Universities.
Not so way ahead, by the way.
Okay.
But they have some
First
distance.
World War. Okay, so when you look at like the universities, like the careers they offer, so the courses they offer, if like a company of automotive, they is maybe measuring, for an example, they'll have that course from a university level. So somebody will study that course from university and then they use it when they get to corporate environment. But in South Africa, I feel like we are still lacking that. So that's why I'm saying in terms of some careers that are being offered in varsity, are they really still advisable for somebody to go and pursue them? And then looking at the high rate of unemployment, you know, like what could also be the cause of high rate unemployment?
So I mean, so I think if one is to give a framework, and I'm thinking about this now as we talk.
Yeah.
You know, you look at the economy. You say I want to be an engineer.
Yes.
How many engineering
Are
companies
they?
do we have in the country?
Yeah.
You say I want to be in HR. Yeah. Are there still companies? Are they hiring? So HR might not absorb all of us, but it's still a relevant career.
It is.
You say, oh, companies, I see their adverts, man. So marketing is still not completely out.
Yeah.
Right? So I think maybe a simple litmus test could be that. And that's I use the example of the operator. You can say I want to be a lift operator, but how, man? These things now anyone can press them.
Yeah.
So clearly I don't have relevance. So I think maybe as a proxy, one can look at it and say, I want to do this. So obviously with things like marketing as an example, right? So marketing has evolved, right? Leverages a lot of technology now.
Yeah.
So you must also check where you're going to study the marketing. Are they incorporating these things into it or not? So maybe it's not so much of don't do that career, but where you're going to learn it,
Okay.
have they evolved
Yeah.
to
yeah.
bring some of these things in our, so like for instance now, if you're going to study a course in energy, and all they talk about is only coal and
Yeah.
nuclear,
Yeah.
it's a problem.
Yeah.
Right? You want to
yeah.
study an energy course that speaks about energy in its entirety, that includes other sources of energy,
Yeah.
other types of energy technologies, right? Because then you are more conversant around the full spectrum, because at some point our envelope of energy technology was here.
Yeah.
Due to the climate change, decarbonization, just transition,
Yeah.
over the years we have opened up. It's not to say the other ones are irrelevant, but the conversation has opened up to include other types of energy sources and energy technologies.
Okay.
So you need to be conversant
Yeah.
in that. The other thing as well to look out for, and I'm thinking about it because you bring in the German example, which I have my problems with that German example, but we can solve that another day, right? You can also
Yes.
check what are companies offering bursaries for.
Yes, and that's the biggest
So
drive
if,
that
so
I'm
if,
also,
yeah, so,
you know,
so if
trying
company,
to
so
push.
even if you don't get the bursary, but if companies are still offering bursaries in certain fields, it means they think
Yeah.
there's still some value in
So I think it's advisable to look at different companies from grade 9, so that when you choose your career or your major subjects in grade 10, then you choose the right majors.
Yes.
Also to look at different companies, like as you mentioned, like the bursaries that they're offering, that also shows the
Yeah.
future.
It's a proxy to say
Yeah.
they still think chemical engineering is useful.
Yeah.
You know? So,
yeah.
but coming back to the other point that you brought now with what happens in countries like Germany. So one of the things we have not done well as a country is along our TVET system. But part of the reason why our TVET system is also not strong,
Yeah.
it's also because our manufacturing is not strong. So
Okay.
places like Germany have a very strong TVET system, and I think it could be because their manufacturing is so strong,
Yeah.
and that
yeah.
manufacturing needs labor.
It does. Yeah.
So then, because the manufacturing demands labor, it pulls the education system to provide that through the TVET system. But our TVET system is quite weak, and we understand that we must get it right, that when it's right, it's the right space.
Okay.
Because here's what you have, and I looked at some of these things because, you know, obviously when you talk about innovation, you have to look at education, because education is among the sources
Yeah,
of
it
driving
is.
innovation in a
Yeah.
particular country. So we have a 3-tier system in terms of higher education, right? You got the university,
Yes.
right, which are supposed to be largely about research, blue sky research, and
Yeah.
here you're not even supposed to care what
Yeah.
companies are doing. So
Yeah.
you're supposed to say, but what must the future look like?
Yes.
Right?
Yes.
And we build that. We do the research, regardless of what's happening in the economy now.
economy,
Right?
okay.
Of course, there's still some undergraduate work and stuff, but largely, those are supposed to be what we call research-intensive universities,
Yeah.
where largely it's looking to the future.
Yeah.
Then you got your universities of technologies, which must start to say, on this research that all these bright sparks and professors are working on, what can we translate into things for the short term?
Yes.
Right?
Yes.
So that's where your China University of Technology come in, your University of Technology comes in.
Yeah.
You know? So there you go now to understand, but what can we practicalize?
Which
out of
is
this thing?
now the
Yeah, which is, because out of all this knowledge, some professor might be flying things to space, and we don't think we want to go to space, but okay, fine. Out of that knowledge, what can we use now?
Yeah.
And this is part of the misconception when people look at the work that Elon Musk is doing, like, no, but why are you sending something to Mars? But the engineering effort to build something and send it to Mars has got a lot of knowledge that you can extract for
Yeah.
other things today.
Yeah.
But someone think, oh, but you're just going to Mars, you're wasting money.
And
No,
that's it.
we're
Yeah.
building an effort. We're trying to test the
Yeah.
boundaries of certain things. Others material. Maybe we're testing how this material do in a hot conditions. I mean, that's why we are able to fly now from here to the US, because certain materials have to be tested that you can actually fly. Otherwise, none of us want to be in that plane.
And that also can help you with choosing where to pursue your higher education. But also, when you want to be in research, it also goes with your grades. So to get into university, you need high grades, and goes to University of Technology and then TVET. But if you just want to choose where, like, maybe you are a high performing learner, but you want to do TVET, that is also possible.
So the other thing is, obviously, then at the end, the TVET, in an ideal system, it's where the things must be made. It's where they must make a chair like this.
I think we also use them wrongly, the way we define them.
That's where the rubber hits the fan. Right? But the other thing I want to add as well is and I think the higher education people now are trying to fix that. So I think from about 2-3 years ago, you no longer have a national diploma. You just have
phased out.
You just have a diploma. You no longer have a BTech. Even up to PhD, it's no longer a doctor of technology. It's the same thing. So the other thing as well is that in a working system, even someone who finishes just to qualify for TVET, 15-20 years later, that person should be able to come out of a university with a PhD.
True. I mean, experience counts.
No, I mean, you enter that system and you get your qualification. Right? When you're done with that, you should qualify to go to a University of Technology. And then you go do your diploma, now your advanced diploma. And then when you're done with that, you must be able, and I mean, at advanced diploma, I think you are at NQF 7. Then from there, you should be able to go to a university and do a postgraduate diploma, which is NQF 9. And then from there, you should be able to do your master's, NQF 9, and then PhD. And then your master, and then your PhD. In a working system, so just because we're now, and this is why higher education is fixed, this thing of national diplomas now, to say, and even high grade and standard grade was fixed precisely because of that. To avoid separate system. To say, yes, I didn't do well come matric. And as we said, someone might not do well come matric because they lost their mother.
True.
But in the past, the system punishes you for life. But now what we're saying is, actually, we must design a system that someone comes at the lower end of matric, enters a TVET, very unhappy about it because they wanted to be somewhere else at vets, and that's a good thing. But we're saying, but no, you must accept your matric marks, enter a TVET, do what needs to be done at TVET, maybe get a job for 2 years, work at some factory. While you're working at the factory, find out where the nearest TVET college is. I mean, University of Technology is. Do your diploma.
But can't you also repeat matric?
Well, there's that option too, but sometimes it's not necessary. I mean, let's be honest. To go and repeat a grade is also not a very nice thing to do.
They say we learn from our mistakes, so maybe that could be teaching you something.
I mean, so you could take that, but in reality,
you can still get a university degree.
You can still move
with
by saying, here's what I got. Let me make the next step. Let me make the next step.
Now, Lord, let's focus on you. So, what was your title like when you started Sasol? What did you start?
So started Sasol, you are called an engineer in training or an assistant engineer. And then you get through a graduate program for about 18 months. Then you can then qualify. You can qualify to be an engineer.
And what was it, like a process engineer?
Yeah, process engineer.
And what were you like responsible for? So I just want people to understand that as a process engineer at a company, this is what you do.
Yeah, so I mean, so I was within the what was called Sasol Technology. It later became Group Technology, which was precisely where, as a whole, there was the research and development team, there was the engineering team, which includes others, but the process. So traditionally, it is process engineers who put the concepts together. and we kind of elevate ourselves, but that's the reality.
Yeah.
Prior to the mechanical engineer choosing the material of construction, I must have put together a process and say I want a process that makes sulfuric acid.
Yeah.
Then later on in the design, we then say, but what is the material of construction that can handle sulfuric acid? Then your mechanical engineers come in. Then I say, no, but I need a pump to move this acid from here to that tank. Then I need a compressor to move air from here to there. Then electrical engineers come in to say, but so how big must the electrical motor be?
Okay.
Then instrument engineers came to now map out, but the basic of a process, that conceptualization is done by us. Either starting to the lab, in certain instances, if it's at the lab, then it's the chemistry guys who start with the test tube to say, like I'm in water now as an example. You have got dirty water. So someone must take that water and say, what must I add to start cleaning this water?
Yeah.
As an example.
Yeah.
So that will probably, now we have the knowledge, but in its nascent days, some chemistry person has to go to the lab and do this test to say how we can separate these. I can dry it in this way. Then from there we put a what we call a flow scheme or a concept together.
Yeah.
Then from there, and that's still on paper. Of course, you can do computer modeling work to test certain things, and later on you can do a pilot where you put a smaller thing of this thing to test.
Okay.
Can I get dirty water in here?
Yeah.
And through this process scheme we put together, can I have clean water there that meets the standard of drinkable water?
Yeah.
Right?
Yeah.
Then from there we saw that now we think it's fine. Let's do the design of the big thing.
Yeah.
When we design the big thing, then you must bring the civil engineers must come in to say, hey, I need the right concrete because I'm gonna put this machine and is this heavy. They will do the calculation to say if you have a machine this heavy, your ground must be done done like this. If you're gonna put a pipe underground, here's how you must protect the pipe so that it doesn't corrode or whatever it is.
Yeah.
So the other disciplines then come in.
Okay.
But so we were part of the design team or kind of thing. But with the R&D, so I did a little bit of the R&D work where I was usually testing catalyst. And so catalysts are, in the basic term, is the things you put to react things, but itself it doesn't react, but it creates the conditions for the reaction to take place.
Oh, okay.
So certain things you want to make when and I mean that was precisely what we're doing. It was an expansion of the of Sasolburg's chemical complex. But to simplify, think about a house. When you're trying to extend a particular house, you must be able to get there and say, but how many rooms am I looking for?
Yeah.
So if I'm adding so many rooms, how many materials do I need? How much money do I need? And if I'm expanding the room for rental purpose, how much money am I gonna make?
Yeah.
Will the money I make pay back the money I'm spending?
Yeah.
And I mean, it's a basic accounting or investment equation. So that's what Sasol at the time was trying to do. So I was involved in quite a bit of the design work, but in some instances we had to do test work. And by test work I mean, and I'll use the house again as an example, right? Someone says that's a double garage.
I know with chemistry you also do testing.
Yeah. So now someone says that's a double garage, but you're not sure. So what do? You must bring 2 cars and park them in.
Yeah.
Right?
Yeah.
And confirm where it is a double garage.
Yeah.
Right? So part of what we need to do in the test work was we think that compressor or that reactor can perform in this way. But we want to test if we can get to that envelope instead of going to buy a new one.
Yeah.
Right? So there was quite a bit of to do a test work, the engineering team has to put together a test plan. They have to go and execute the test plan. They have to understand the risk about the test plan, gather the data, come back and say, and it must be run for a particular time to have confidence. It's like even any car goes through testing to see when at the end every car you buy is with a spec. 0 to 100 kilometers.
Yeah.
We're not just writing.
No, we have to test it.
Someone tests that
and
test it at a particular space, even emissions.
Yeah.
They have to do that and say, this engine, it's been optimized, but it still has so much carbon dioxide emissions, or even energy consumption, or the capacity. I mean, the boys love the kilowatts of cars. That has to be tested. That we've designed it, but can it do 184 kilowatts, or is it
all cars that we
165 or whatever?
manufacture, they get like tested on the actual road before they
Exactly. Or at
go to
least
the
test, or
market.
at least if they are done around the same batch. They,
100%.
there are rules of thumbs where you can say if you test 30%, it's fine. And,
Yeah.
and those are part of engineering guidelines where you can say
Yes.
you test. It's like now, I mean, I lecture at West Business School. So when I submitted the script, they only took 30% of the script to the external examiner.
Okay.
Yeah, so they say if
30% is good.
no. If the examiner looks at 30% of the scripts
Yeah.
and finds that I'm consistent,
Yeah.
it means I was consistent on 100.
Okay.
Yeah. So it's
that's
rules of
interesting.
thumbs that
Yeah.
you that you use as you go along, and even in cars. So not all cars were tested on the road. They will have been made with the same process. Then you'll randomly take maybe 10% and go test them. If there are no issues out of that, you say no, everything is fine. But of course, that's where your warranty and whatever comes in, because there will still be some defects. Because if you had to test all 100 of them,
No. In terms
it would
of
be-
kilometers, yeah, obviously you're not gonna do like 100%.
Yeah.
But I'm just talking about like a short distance.
No, but even that, you won't do.
We do.
You wouldn't do that in all of them.
We do in all of them. It's not all of them.
No. How much money are you gonna have to be able to do that? Because you need people. You need.
Yeah.
So I mean, a business has to make a business decision.
Yeah.
Right.
So with like the field that you're in, are there a lot of ladies? So the reason why I'm asking, I'm in the engineering space and we don't have a lot of ladies. And when looking at hiring ladies, we always look at hiring from universities. But there is not enough pull from universities, which also made me start this project that we need more ladies in engineering, because I've got an engineering background. Into engineering space from high school, they need to know that engineering is not just about like manual work. So did you guys have a lot of
Yeah, I mean,
ladies?
interesting enough. I mean, chemical engineering had a lot of ladies. Even now, I mean, the CEO of the water company I'm part of,
That's
it's a lady. She's a civil engineer by training.
That's good.
Yeah, and
Okay.
we've got even in my team, actually, we've got we've got ladies as well. So I mean, I think it does differ, but I think there's also an element of we must always think about the evolution of these things,
Yeah.
right?
Yeah.
I mean, the word mechanical sounds very masculine,
Yeah.
you know.
Yeah, it does.
But the reality is that today a mechanical engineer can do a lot of work
Yeah.
on the computer,
True.
and even
I'm
when they go to
working
the
with the computer.
yeah, but even when they go to the field,
Yeah.
yes, they have to wear safety clothes, but they just go in there to check, you know, do the lines look as we have them in the model, and stuff like that. So it's not as manually intensive as it is, but even then you've got a crane, you've got.
But you're not going to be driving a crane if you are an engineer,
So
unless
true,
if you
true, yes.
want to have an experience with driving a
Yeah,
crane.
exactly. So,
Yeah.
but the point I'm saying is, in the past, you probably needed to carry these things around.
Okay, yeah,
but
yeah.
today, and hence I use
Things have evolved.
things have evolved, and you know, you can be in the field and you can just check at the end, or, oh yeah, the welding was done correct, and you can check your hit numbers and whatever it is, and confirm it's as you wanted it, and then that's it.
Okay.
So there is an element of that, and I guess it goes back as well to demystifying from a much younger. I think just as part of the conversations to say, but then also even as a mechanical engineer, within, and I think this is a very important point, within each discipline, there's sub-disciplines.
Yeah, true. I think we only look at like the just discipline as a whole, but we don't look at the
So even
subs.
within, and that's what I'm saying, even within my space now of innovation, I mean, innovation cuts across, there's space of just idea generation.
Yeah.
People just must just generate ideas. There's spaces of now testing the ideas in the lab. There's now spaces of building those things.
Yeah.
There's also spaces of now we are operating it, how do we optimize it? So it's still innovation.
Yeah.
Yeah, and within innovation, there's still sectors. You can do it in retail.
Yeah.
You can do it in banking. You can do it in aviation.
Yeah.
So I think we must not see a career and say, you are just stuck at go airport if you're in aviation. No, now you can be building drones
True.
with the same knowledge.
True.
Yeah.
So, you're currently working for, like you're in corporate.
Yes.
Would you like to stay in corporate or have a business, or would like to start a business one day and leave corporate?
Right now, I'll do both.
Okay.
Yeah.
Okay.
I don't think you necessarily have to choose.
Yeah.
At the moment, I think I'll continue doing work in corporates. But looking at my skill set, I'll see what services I can offer
like consultation.
at a monetary value.
Okay. Yeah.
And as I move along, I might decide otherwise. But it does not always have to be. It does not always have to be either or. And